What's up, team? 30, 60, 90 triangles coming your way. This is the second of two videos on special right triangles. Please view the other one first if you haven't already, because I'm going to be moving a little bit quicker through this one. Okay, all of these are called 30, 60, 90 triangles because they have angle measures of 30 degrees, 60 degrees, and 90 degrees. For those of you scoring at home, you add those together, they equal 180, so it works. These are all similar regardless of size, so we're going to explore some ratios between the leg lengths and then the hypotenuse and the short leg, or call it leg A. So for this first one, I'm going to give you some of the measurements here, and I'm going to ask you to do a little bit of trusting of me. I'll show you that it definitely works for a right triangle, but in terms of these specific ones, I am going to ask you to play the Truss game just a little bit for us here. So again, being as simple as possible, if the short leg has a length of 1, then let's explore a triangle with the following measures here. So the short leg has a length of 1, the hypotenuse has a length of 2, and the long leg has a length of the square root of 3. Now, it seems like I pulled those numbers out of nowhere. I kind of did. But let me show you that they work definitely in terms of them forming a right triangle, that they're a Pythagorean triple. This kind of harkens back to learning target, I think 12.3, when we showed that triangles were, or right triangles were indeed right. So I'm going to do a squared plus b squared equals c squared and just see what happens. In this case, it's 1 squared plus the square root of 3 squared equals 2 squared, and again, question mark because we're not certain yet. 1 squared I know is 1, square root of 3 squared I know is 3, and 2 squared I know is 4. In this case, 4 equals 4, so it forms a right triangle. Now, the fact that it's specifically a 30, 60, 90, I am going to ask you to trust me on that. We can have that discussion a little bit more later in the future. So what I'm really interested in for this lesson is looking at the relationships between these side lengths here. So here, the first relationship I want to look at is leg B over leg A, and then I want to look at the hypotenuse over leg A as well. Leg B is the longer leg. That's how I differentiate these. The short one I call leg A, the big one I call leg B. If you flip-flop that, fine. As long as you know what you're talking about, that's a win. I'm doing the shorter one as A, the longer one as B. So my leg B in this case has length root 3. My leg A in this case has leg length of 1. So the ratio here, or the multiplying factor, is just the square root of 3. Let's look at the other one. Hypotenuse to the leg A, which is just 2 over 1, or 2. What this tells us is if we have the length of the short leg, and you want to find the length of the hypotenuse, all you need to do is double it. Easy peasy. Now, if you have the short leg and you want to find the length of the long leg, all you need to do is multiply it by the square root of 3. Easy peasy. Now, it's a little awkward because that square root of 3 is another irrational number, but it does the trick. So, in general, if you have some value for the short leg, we'll call it x. It can be anything. It can be a whole number. It can be 1. It can be a million. It can be 18.62 pi million, whatever. It doesn't matter. All you need to do to find the hypotenuse is double it. Whatever that number is, multiply it by 2. And to find the length of the long leg, you take that x value and you multiply it by the square root of 3. So to check those ratios out, to make sure that they match over here, leg B over leg A, if we have x root 3 over x, long leg over short leg, the x's of course cancel and we end up with that same exact ratio. That's why this is true. So this is an example of a specific case, and this is a general case. In the same way, the hypotenuse over leg A, just 2x over x, x's cancel, and you get that ratio of 2. So if I'm you and I'm taking some notes, this chunk right here is huge. This needs to be in your notes. This needs to be with you on quiz day. This is going to be our resource. Let's practice using this as a resource with 2 quick examples, and I'll wrap this up. So this one here, we have a 30, 60, 90. It's kind of oriented a little bit differently, but it still works. We have a hypotenuse. We're seeking the lengths of leg A and leg B. We're going to use these ratios. A couple different ways you can approach this one. There's kind of the shortcut, fast way that I think a lot of you will adopt, but I'm going to show you what's going on behind the scenes before I show you that way. So these ratios, if we want to find one of these pieces here, we only have the hypotenuse, so we're going to use this ratio with a length of 2. So we're going to say the hypotenuse over leg A. So in our case, that's 12 over A equals, well, it's going to equal 2. And we need to untangle this mess to get A all by itself. So I'm going to multiply both sides by A, and we learn that 12 equals 2A. Now, of course, divide both sides by 2, and we learn that A equals 6. So in this case, we have a leg length of 6. Now, the shortcut to this, of course, is we know that the hypotenuse is twice the length of the short leg. You could have just said, well, half of 12 is 6. Therefore, the short leg is 6. Yeah, you can definitely do that. But what's going on behind the scenes is that these ratios are at play. That's why it works. Okay, so we have this. Now to use this idea to find the length of B, or the long leg, we are going to take our shortcut. We know if we have the short leg, just multiply it by root 3 to get the long leg. So this is going to be 6 times the square root of 3. Now, as I talked about in the last video, I love me a decimal approximation because 6 times the square root of 3 is really hard for me to picture what is happening. I think it's going to be like 9.5-ish, something like that. But let's check. So I'm typing in my calculator. Square root of 3 times 6, and I learned that I was wrong. It's going to be approximately 10.39. So I was close, but I'm glad I checked out that decimal approximation because I can't picture that in my head. 10.3, I can picture that in my head all day. So I'm looking for a decimal approximation. Again, disclaimer, similar to the last video, this is an exact representation of the value. This is a rounded number. It's a decimal approximation. Some math teachers in the future might be really picky and will never want to see a decimal approximation. They only want to see the exact. I think it's helpful to get the approximation so we can picture what's happening. But be aware of that in the future. Okay, last one. We're going to find A, we're going to find B, and we're just going to use our shortcut here. It's going to be a little bit wonky, though, because we only have the long leg in this case. So we have kind of the x root 3. So what we need to do to go from x root 3 to x is just divide by the square root of 3. So we're going to take our 100. So hang on. A equals 100 over root 3. And again, that's gross. Use your calculator, please, please, please. If you don't have one, TI-30, they're like $12. Please, please get one. I don't have one for you in the classroom. I can show you how to do some of this on your phone, but not on quizzes. Get a calculator, please. All right, so 100 divided by the square root of 3, and my calculator tells me it's 57.74. And again, it's approximate 57.74. Now that we have that 57.74, that's our A value. To find the length of the hypotenuse, we just double it. Because if we have this length, we double it to find the hypotenuse. So I'm just going to my calculator, clicking times 2 from that previous answer, and I learned that C has an approximate value of 115.47. So I have found the length of the short leg and the length of the hypotenuse, and all I had was the length of the long leg. These ratios are a huge shortcut. They're like a cheat code, whatever language you want to use there. Ratios with triangles are not going away. This whole unit, the next several lessons, are going to talk about different ratios that we're going to explore with triangles. So here you go, 30, 60, 90 triangles. Check out some practice problems. Ask me all your questions. You got this.